Morning students, today we are starting with the 10th unit of the 11th class chemistry, that is S block elements. Question number 1, give electronic configuration of alkali metals and alkaline earth metals. Alkali metals. We have the metals with hydrogen, polynoc, rough phosphor. Atomic number starts from 1, it is 3, 11, 19, 37, 55, 87. General configuration 1s1, this is helium, 2s1, then we have neon configuration 3s1, argon 18 wali, then we have 4s1, krypton 36, 5s1, xenon 54, 6s1, and then we have radon 86, that is 7s1. So this is the general configuration of alkali metals. Then we have alkaline earth metals. We have the elements beryllium, magnesium, calcium, strontium, barium and radium. Being का 12. So this is 4, this will be 12, this is 20, 38 and 56, 88. We have the configuration helium 2s2, then we have neon 3s2, argon 18, then we have 4s2, krypton 5s2, xenon 6s2, radon it is 7s2. So general configuration, they have NS1, they have NS2. So this is the electronic configuration of first and second group. Then we have very important question number 2. Why group 1 elements are called as alkali metals? Answer is, since they form strong alkalis on reaction with water, so their alkali forming capacity or capability earns them name alkali metals. They form strong alkalis on reaction with water, so alkali forming elements named as alkali metals. Then we have question number 3, why group 2 elements are known as alkaline earth metals. It is again the tendency on the part of group 2 element to produce alkalis on reaction with water, and the capability of their oxides not to be affected by heat. They behave just like alumina, which is popularly called as earth. So number 1, they have alkali forming capability. On reaction with water, and heat resistant action of their oxides, just like earth. That is alumina, popularly known as alumina. Alumina is not affected by the action of heat. Similarly, these oxides, they are also not affected by heat. So combining these two properties, first is formation of alkalis by these metal on reaction with water. Second is the heat resistant action of these oxides. Both of these factors, they fix name to these metals as alkaline earth metals. Then we come to another question. Comment upon the sizes of group 1 and group 2 elements. So that will be our question number 4. Comment upon the sizes of group 1 and group 2 elements. They have small sizes in their respective periods. It is mainly because of the large sizes in their respective periods. Question number 4 is comment upon atomic sizes of group 1 and group 2 elements. Answer is alkali metals have largest size in their respective periods. Alkaline earth metals from second in order of sizes. And atomic size increases from top to bottom. In their respective groups. So this is regarding size of these elements. The increase in size from top to bottom, it is due to increased number of cells and increased screening effect of the intervening electrons. Then we have why ionization enthalpy in decreases from top to bottom. In the each group. The answer to this problem is very simple, that when we move top to bottom, the atomic sizes continuously increase. Therefore, the hold of the nucleus on the valence electron that decreases, which decreases the value of ionization energy when we move top to bottom in the family. Then we have what are the oxidation states of group number L. Oxidation states of group number 1 and 2. So answer is group 1 has oxidation state of +1, since they have only one electron in the valence shell which can be lost to acquire +1 configuration. Then we have group 2 element, they have +2 state by losing 2 s electrons of the valence shell. Then comment upon melting and boiling point. Group 1 and group 2 elements, they possess low melting and boiling point. It is due to weak metallic bonding among their atoms in their lattice, and the melting and boiling point that will increase when we move top to bottom. Lithium and beryllium, they possess high melting point. It is because of their covalent network of their small sized atoms. And the melting and boiling point, if we compare these two elements, group 1 and group 2 element, the melting and boiling point of group 2 elements is higher than group 1 elements. It is due to strong metallic bonding in them. So this is regarding melting and boiling point. Why alkali metals are softer than alkaline earth metals? The reason is same. Why group 1 elements are softer than group 2 elements? The reason is same. Group 2 elements, they possess strong metallic bonding, that's why they are a bit harder as compared to alkali metals. Alkali metals have only one valence electron in their valence shell, which possess weak metallic bonding. That's why they are soft, they have low melting and boiling point. They are so soft that they can be even cut with knife. So alkali metal luster is weak as compared to alkaline earth metals. Then we have next question, out of group 1 and group 2, which has a high hydration energy? So out of group 1 and 2 elements whose ions possess high hydration energy, answer, the small size ions of group 2 elements, they have more tendency to get solvated by a more number of water molecules and they release more energy due to their small sizes. So you can say the group 2 ions possess high hydration energy. Due to their small sizes. They get heavily solvated by water molecules and release lot of energy during their solvation or during their hydration. Then why alkali and alkaline earth metal, they give color to the flame? Why they give color to the flame? Let us short reason for that. Beryllium and magnesium, due to their small sizes, they do not give color to the flame. But other elements of group 1 and group 2, they provide color to the flame. Why alkali and alkaline earth metals give color to the flame? Answer, it is due to excitation of their valence electrons. Since they have low ionization energy, they can easily excite their valence electrons by absorbing small amount of energy from the flame in which they are heated. That's why these electrons, when they get excited, move to the higher levels, but these higher states or excited states of the electron, they are not the permanent state. After some time, electron has to release the absorbed energy in the form of photons of visible light, and these photons, they impart color to the flame. So if this question is asked why alkali metal give color to the flame, reason is very simple. They impart color to the flame due to excitation of valence electron, for which merely a small amount of energy is needed, which is obtained from the flame, and these excited electrons, when return back to the ground state, they give color to the flame. For example, lithium gives crimson red color, sodium gives golden yellow color, potassium gives bright yellow, bright yellow color. So these are the three alkali metals giving color. Then rubidium gives violet color. Cesium gives blue color. Blue color to the flame. Then we have radium gives grassy green color to the flame. Strontium gives crimson red. Calcium gives brick red, just like brick. Then we have the barium, it also gives the grassy green color to the flame. So these are the color imparted by the alkali and alkaline earth metals to the flame. Then we have few metals which do not give color to the flame. Why? Beryllium and magnesium. Do not give color to the flame. It is due to their small sizes and high ionization energies. They are not able to excite their valence electrons by taking energy from the flame, because that energy is less energetic. So they are not able to excite their electron. If the electrons are not excited, then what will come out of excited state? There is no excited state obtained in these cases. So beryllium and magnesium, due to their small sizes, high ionization energy, and the incapability of the flame to supply that much high energy to their valence electrons, the color is not obtained in case of beryllium and magnesium when they are heated in the flame. This is all about our first lecture of S block element. In the next lecture we will be taking the chemical properties of these two groups.